So this is the 2014 Leaving Cert Higher Level Paper 2, and we're looking at question number 2. Part A says prove that the cos of 2a is equal to cos squared a minus sine squared a. Okay, so what you need to spot here is that the cos of 2a, we can express that the left hand side, we can say that's the same as the cos of a plus a, because 2a is just a plus a. And once you spot this, once you split the 2a into a plus a, you're then allowed to use this identity here from the tables book. Cos of a plus b is equal to the cos a cos b minus sine a sine b. So we can say then that that's equal to cos of the first angle by the cos of the second angle. So in our case, both angles are the same, minus the sine of the first angle by the sine of the second angle, again the same. And that gives us cos a is cos squared a, and sine a is sine squared a. And that is the right hand side. So we can say equal to the right hand side, or HS. So there you go, that's the proof done for part A. Part B, the diagram shows part of the circular end of a running track with 3 running lanes. The center of each of the circular boundaries of the lanes is at O. So here's O here. Kate runs in the middle of lane 1 from A to B as shown. Okay, so I'm just going to use my highlighter here. So this is Kate, A to B, in the middle, so that's this track here, this broken line here. She's following that track from A to B, that's Kate. Helen runs in the middle of lane 2 from C to D as shown. So here's Helen. She's running from C to D along this broken line in the middle of that lane, like so. Helen runs in the middle of Helen runs 3 meters further than Kate. So this green distance is 3 meters longer than the yellow distance. The size of the angle AOB, so the size of the angle AOB, so from A to O to B, so this angle here, is equal to the size of the angle COD, so C to O to D, which is equal to theta radians as marked. Okay. If each lane is 1.2 meters wide, find theta. So each lane is 1.2 meters wide. Well, what that means is that the distance at any point, such as here, or anywhere around there, that's going to be 1.2 meters apart. A and C are 1.2 meters apart. Okay, so we've defined theta. Right, so it looks like we're going to have to set up an equation here because they do give us the info that Helen runs 3 meters further than Kate. So we know the green distance is 3 meters longer than the yellow distance. Okay, so how are we going to find the yellow and the green distance? Well, the length of an arc, there's a formula for this in your tables book. And the formula is, if the angle is in radians, which we can assume it is from here, the length is r theta. This formula here from the tables book. So this length, L, is equal to the radius by the angle in the arc in radians. So L equals R theta. Okay, so we can then say that the distance from A to B, that distance from A to B is equal to the radius, which we don't know, so we'll just leave that as R theta. And then we can say, so that's our distance for Kate. This is A to B, that's R theta. And then we can say the distance from C to D, that distance is equal to R plus 1.2, because this radius from O to C is 1.2 longer than from O to A. So it's r plus 1.2 by the angle, which is theta again. So that's our green distance by the formula in the tables book. Okay, so we know our yellow distance and our green distance. And now we're going to set up an equation using this information here. Helen runs 3 meters further than Kate. So that means that the yellow distance plus 3 is equal to the green distance. In other words, r theta plus 3 is equal to r plus 1.2 by theta. So some people get mixed up there and they add the 3 to the green distance, but it's the yellow distance that's shorter. So the yellow distance plus the 3 is equal to the green distance. So again, just to be clear there what I'm doing, we have the r theta plus the 3 equals the r plus 1.2 times theta. Okay, so now we have an equation. We have two unknowns, r and theta. And we're looking for theta, remember, we're looking for theta. So we're hoping now that we can sort this out and maybe the r might disappear. So let's see what we've got. We've got r theta plus 3 on the left. We leave that alone. I'm going to multiply this out now. So the theta gets multiplied by each of these here. So that's r theta plus 1.2 theta. Okay, so I can see now from both sides I've got r theta, so I can actually take r theta away from both sides, and that leaves me with 3 is equal to 1.2 theta. So theta, the angle I'm looking for, if I divide both sides by 1.2, these cancel. So theta is 3 divided by 1.2. So 3 divided by 1.2, that gives me 2.5, and that's with theta in radians, because this is the formula I used, which has theta as radians. So my units are radians. Radians is just another measure for an angle. It's a different unit to degree, but it still measures angles. So that's the end of part B and the end of question number 2.